Hello guys, my name is Mohsin and today I'm going to show something about waxman graph. We will discuss little properties about waxman graphs. I will calculate clustering coefficient and draw a graph for 1000 nodes, and we will keep the alpha value constant on 0.15, while I will change the beta value from 0.2 to 0.4 to see the behavior on clustering coefficient, first theoretically, and then we will see visually the graph. To generate Waxman graph, I'm using networkx library, which is in Python, while for visualization purposes I'm using matplotlib, uh, which is quite famous for the plot and visualization as a tool in Python. So let's start. Here I am going to give the command python project py, and here I will start my simulation. So it's generate the clustering coefficient, calculate the clustering coefficient 0.0449 on beta value 0.2, and it's trying to generate the graph and show it on a plot. So here is our graph. As you can see, it's quite congested, so and unreadable. So let me zoom it from the bottom. So here, let me zoom it. So as you can see, nodes have labeled here node 443, here 393, 664, and it is quite attached graph, as you can see. So no, these are the edge nodes, but still it is quite attached. But if we will go in between, like let's suppose I will move the graph a little inside, so you can see it's quite dark, while nodes are really attached in between, so we cannot even distinguish between nodes here. So let me close this graph, and then we will calculate the characteristic coefficient and generate the graph on beta value 0.4. So I am waiting. So here is the clustering coefficient, so it's now 0.068. so from this value, as the previous value, it's 0.04, so we can see like the clustering coefficient increased when the beta value increases. So it means the graph will have more attached property. It will be more attached. So let's see, as it's, we can see it's more attached from the node, so it's quite congested again. So let me zoom it. Here it is, we can see the labels 848, 116, 402, and it is quite attached from even the edge as compared to before. So let me move a little in the center to study it. So as you can see, it is quite dark inside, so it is quite attached, like the nodes inside in the center is really attached a lot. So here we are studying the clustering coefficient. So let's suppose now I am going to calculate the confidence interval for the clustering coefficient while varying the values from 0.2 to 0.4, and I generate the uh, graph line for clustering coefficient and beta values with the confidence interval. So here is my calculation for that. So as you can see, for each beta value I calculated 10 times. For coefficient, clustering coefficient, as it's generated by random, so each time the clustering coefficient value is different from the other, so we will take then the mean and then calculate the confidence interval for that with beta value, and then we do our calculations. It's like for each beta value. So I am incrementing here with this step, which is actually 0.02, and at the end we have like coefficient array, which actually give us the mean coefficient of each beta values, and here we have the confidence interval, which is calculated on each beta value. and here is the time lapse, total time lapse, which is actually represented here like 185 seconds, and the graph which is generated by this is here. So as you can see, the points on the graph as the exact locations which are actually the giving us the beta value and the clustering coefficient range, and blue line on top of it is representing, which is in the dashed, actually the clustering coefficient upper limit, which includes the uh, confidence interval, and the green line which is below is representing the clustering coefficient lower limit, and it includes the confidence interval, which is mean confidence interval. So this is actually the graph which is actually beta versus clustering coefficient with confidence interval. So I hope you like this session. So it's good. Thanks. Bye.